Welcome to Let's Code. We're working on the Lunar Lander project, and I'm here with Umang. Hello.
Hi.
So I'd like to get your input on where we are with this project right now, because I know you're also working on a game yourself. That's right, isn't it?
Yes, I am.
And you've prototyped it by developing it in main.go, so main-driven development. And now you're kind of in the process of adding tests and refactoring that into a package.
Yes, that is correct.
So we're at more or less the same point with this, in that we have a working game, not the world's greatest game, but it works. And we now would like to get this covered by tests, and we'd like to turn it into a proper library. So we've partly done that. Josh and I did some more moving stuff into testable functions last time. I think we did this, so okay, it's one line, but took us a while to figure out exactly what that line should be. It's often how it goes, isn't it?
Yes, it does.
So I thought we might look at doing a little bit more of that. There's one thing we haven't done yet, which is we haven't refactored this code to use our new display state function. So
Okay.
What we're doing is basically going through the code in main.go, thinking, can we take this chunk and move it into the Lander package, and then add a test for it, and then call it from here. So we did that with the world setup stuff. Then we did it for printing out the state of the world to the player. So we can refactor that, and the next bit would be getting input from the player. The only control they have at the moment is how much rocket thrust there is, but nonetheless we need to ask them for that. We need to read that from the keyboard.
Right.
And I know you're doing that in your game, so your expertise would come in quite useful here for figuring out
Right.
how to design and test that. And then we have some physics update stuff to do, and then we're more or less there. So what do you think? Shall we start with finishing this refactoring and bringing display state in here?
Yes, let's go for it.
Okay. So we have a little bit of a problem in one sense, because if we look at altitude and velocity and so forth, for example, these used to be global variables in main, or local variables in main, and we referenced them directly. Now we've moved that init stuff out into another function, so we don't have them here anymore.
Correct.
So, we were looking at this and we said, okay, the thing is, actually, we're going to end up with virtually no code in main at all, aren't we?
Yes.
We want it to be something like just lander.run game.
Correct.
So this problem is only temporary, really, isn't it? It's like we're trying to reach into the package and see stuff that's not available. So we've actually replaced this already with display state, which means we don't need to know the altitude. But we are inside this loop where, essentially the game loops as long as the lander is still not landed.
Yes.
So we need to know altitude for that. So that's going to be another little design problem for us, is how, should we move that loop into the package wholesale? Or should we provide something like for lander dot not crashed? Bike shed the name later, but something like that.
Correct.
So let's sort out the contents of the loop.
Yes.
So we now have a display state function which it takes some IO writer to write to.
Correct.
Because we're not going to print it to the terminal, because one, we don't want to see the terminal output during the tests, and two, we want to see what was written. We can't really inspect the terminal, but what we can do is create a fake terminal,
Correct.
bytes buffer, let's say, pass in a pointer to it to display state and say, hey, write to this. Then we can look at it to see what was written. we can replace this with what? Lambda display state, and what writer should we pass to it?
Which is the writer that we can we go back to the other one basically, please? This is let's look at this.
Yeah, so here's the code.
Yeah, function the display state writer. Yeah, basically we could probably, this is coming from for the actual game. It will be coming, this is for the test or for the actual game?
This is for the real game. So
this is for the real game. So it would be coming from the command line stuff basically for the game, right? Where people will be entering stuff.
Yeah.
So that's what we will have to enter stuff. It will be it will have to be a reader first, right? Or will be
for reading the thrust setting, yes, it will. So, but for displaying the state, we only need to write. So we can pass it anything which is an IO writer.
Yes.
What could we pass here if we're happy to write to the terminal?
Like a scanner stuff?
Yeah, we can use the scanner for reading the thrust setting, definitely.
Yeah. So the writer stuff's basically, I have to refer to my old game as well now.
Yeah, well, suppose we pass it os.standardout.
Oh, os.standardout, that would work in this case, yeah.
Because that's a writer, isn't it? So
yes.
And it also has the side effect that it prints to the terminal.
Yes.
This is fine to do. We could imagine, a more sophisticated output. Could be in a GUI window or something like that. But for the moment, let's just say terminal.
Okay.
So we've printed out to the standard out. Now we want to get that thrust setting. So
we get it from the stdin.
Yeah, sounds believable, doesn't it?
Yes.
So what could we call this function? Lambda something.
Lambda.input or something.
Yeah, input what? What about input thrust? Or,
yeah, input thrust.
Let's write the test.
Let's write the test for the lambda input thrust. Yeah.
Yeah. So let's get rid of some blank lines, because especially with the big font, it's just like we only have about one line on screen at once. So we could copy and paste from another test function, but let's keep it simple. So what are we calling this then?
Test lambda input thrust.
Yeah, we know it's lambda, so how about
input thrust? Input thrust. Okay, yeah.
Or when you call the function, that does not input the thrust. What the function does is ask the user to input the thrust.
Correct.
And then get it. So, is there a better name for this?
Test ask for thrust.
Something like that. Yeah, it feels like
something
a better
like
name. Or prompt.
Prompt thrust. Yeah, prompt thrust works. Yeah.
Or maybe the thing is, one idea we have is we would like to have real-time control. So rather than the game pauses and waits for you to think about it and you type in your answer, obviously a real lunar lander wouldn't do that.
Yes.
Time would be an issue. So we would maybe like to do something like just sample the keyboard, see if they're pressing a key. So you have. You don't have to type and press enter, you just press the key for throttle up or something like this. So
yeah, just the arrow keys up and down or something like that, right? In that sense.
Yeah, so if we generalize this, maybe we're not even going to be prompting for the thrust in future. So this is the number one hard problem in computer science, isn't it? Naming things.
Naming things, yes.
And it's... in some sense, I think your code can be as terrible as you like, as long as your names make sense. It's still easy to understand your program. If you have the most beautiful code in the world, but none of your names make any sense, it's going to be impossible to follow. So this is an important thing to think about, isn't it? So what about something like just get thrust What about read thrust?
That's what I'm going to read thrust, or maybe just I was thinking about the read thrust. Yes, read
Yeah.
thrust is easier,
Okay.
simpler.
Because that's not assuming that it's going to be from standard in or anything like that. We could just be
Source
reading
can
it
be
by.
anything. Yeah.
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 So that's good. We also don't want to go down the rabbit hole of bike shedding the names too much, do we? Because we could sit there all day arguing about the perfect name, ask me how I know, and not actually get anything done. So we know we want T parallel.
Yeah, we want T parallel. Yes.
What's next?
I don't. Do we want? I think we don't really need the. Do we need the init game here step, which like the earlier one? Probably.
That's actually a great question because
Yeah.
we have right now init game is just kind of global in that it writes to this global game state variable, and that's clearly not a good idea in the long term because we might, you could imagine running this game as a web service where 100 people are each playing their own game concurrently, aren't they? So
Yes.
clearly, global game state's not going to work for that. And similarly with the tests, each test would like to manipulate the world in some way, and
Correct.
not have the other tests interfere with it. So we've kind of punted that question by just calling init game.
Okay.
But what could we do instead? Like what are our other options if we want to be able to have a separate game state in each test, let's say, for simplicity?
Yeah, we will need to instantiate it separately because I've been doing something similar in my game where we're trying to not have a global web, but define within each instance of calling the game, right? Where we have their own set of variables.
Exactly right. Yeah, it's a new instance of the game, isn't it?
Correct. Do we have something like that here, or
not yet?
Not yet.
But the day is young. It feels like a struct, doesn't it?
It feels like a struct, absolutely. It will be a struct, yes.
Like any time you've got some kind of state that you want to pass around, whether it be a server object or a client object, or in this case, I suppose a game object.
Yeah, so we could potentially define stuff basically, right? We come with a struct like, this is what we want, this is what we got.
Yeah, I think that's quite important, isn't it? So I kind of want to get that sorted out straight away. Do you mind diverting from the reading the thrust thing just temporarily while we sort out this
No,
game
that's great.
structure?
That's awesome.
We need it, don't we? So
yes, we need it.
suppose instead of init game, then we just named it new game or something like that, and actually have it return the struct.
Yes,
What about that?
that works.
Okay, so suppose because we need to create that struct somehow, and
Yes.
we also need to set initial values for everything, so we can kind of do that in the same place.
Correct.
So what's our want here? Well, it's kind of the same, isn't it?
Yes. This is just starting a new game want state would be the same thing. Yes.
Yeah, suppose instead of lambda.state we call this lambda.game,
Yeah.
and that broadens it out a little bit, doesn't it? So can I rename this? Yes. Good. That makes sense to me. So so now we're going to say new game, but we need to return something, don't we?
Yes, we need to return the one state. Yeah.
What shall we call the thing that we get back?
Got state.
Yep.
Pretty obvious there.
Or
Yeah.
actually, it's got game, isn't it?
Got
Because we're saying
game.
it's,
Oh, that works. Yeah.
So want game. Well, let's just call it want and got, since
Yeah. Want and got is simpler. Yeah.
so fine. That's want. This is got. Good. All tests kind of end like this, don't
Yes.
they?
Yes.
Does it also need to return error, do you think?
no harm in sending error back, which should be it's not able to initialize or start a new game for any reason. But
Yeah,
probably not in this case, I'm thinking.
yeah. Well, we don't have anything which could error right now since
Yes.
we're just creating a struct.
Yes.
Here's the code.
Mm,
But
there's-
but maybe you could imagine new game could take some parameters like what type of game, difficulty level, for example.
Correct.
And so maybe those inputs could be bad. You know, anytime you've got input, the input could potentially be bad, couldn't it? So you probably need to return error. But
At some point you will need that, or maybe not. I'm just wondering. We don't have much right now, but we could put. I think we could put the plumbing for it in there.
yeah, so it's often have this kind of decision to make, don't we? Is we probably want X, but should we do X now or wait till later?
Let's do it, John.
Yeah, okay, let's have it return error.
Yes.
And we can assert that it's not nil.
Mm-hmm.
And it's fatal
Mm-hmm.
if it is. Right now we know it won't.
Mm-hmm.
Let's just fix compile issues. See, I told Josh not to write anything here in the comments because I said whatever you write, you're going to end up changing it, aren't you?
Yes.
And I've proved myself right. I just want to take a moment to tell you about a series of ebooks I'm writing for Go beginners called For the Love of Go. In Book 1, Fundamentals, I show you how to write tests in Go and how to build programs test first. In Book 2, Data, I tell you all about variables and values in Go and data types like slices and structs. If you're new to programming or just new to Go, I'll show you everything you need to know to start building fun and useful projects. Go to bitfieldconsulting.com/books and enter Code Club at the checkout to get 25% off now. So I am actually quite relaxed about ignoring these yellow lines from VS Code telling us that the linter is prompting for a comment. As a mentor, I am prepared to enforce documentation comments, you know, with lethal force if necessary. But the time at which I do that, you know, is not day one, or even maybe day 3. It's sort of like, you know, what's the ideal time to finalize your documentation? Probably just the minute before you release it, isn't it?
Yes.
Because you know you're not going to significantly change the functions that you have or the names of things. And if you leave it any later, of course, you'll be releasing it without the docs.
Correct.
So that would be bad. But we know we're not there yet.
Mm-hmm.
So, are we passing? No. Why not?
No value used as value compiler. Render.new game.
Let's go side by side here.
Let's going to go side by side. Let's take a look at that. Yeah. There we go. So there's no input for that. We're not returning error from that. We're only returning. Are we returning? We're not returning anything there.
Yeah, right.
The function new game.
Right.
Mm-hmm.
So we can get rid of this global. We don't need any more. That feels good, doesn't it?
Yes.
Always love to delete global variables. This game struct, yeah, that's fine. So now we're saying this returns what? Game
Yeah.
and error.
Yes, game and error.
Okay.
Mm-hmm.
So we don't need to assign anything. We don't need to assign that literal to anything. We can just return it, can't we?
Yes. Mm-hmm.
For now.
Yep.
And nil.
Nil. Yes. Mm-hmm.
Yeah, that seems right.
That's right. Yeah, the red squiggly line is gone.
Okay. It's not T fatal F. It's just T fatal. Because if I wanted to say something about it, you know,
then you're reformatting it, right? Yeah.
I could say like, oh no.
Yes.
but that's sort of implied, isn't it?
Yes.
So I don't need that. Okay. We've got rid of some red lines here. We've got some red lines here.
Okay, that's the different. We're no longer have the game state.
Yeah, I'm not going to be able to run my test yet because the package doesn't compile. So
Because we have the init games on the left becomes a new game.
Yeah, should we fix these first?
Yeah, let's fix it. Yeah, let's fix it. Yeah. The function display
So,
state thrust. What
yeah,
is the function then?
let,
That's a simple one.
let's fix this up so
Yeah.
that we get... We're not interested in the error here because we're not testing new game. We already
Yeah.
tested that. We're just saying, give me a new game that I can test something else with. So I'm going to comment that. Just because I always want to make it super clear to anyone reading it. You know, I'm not just being lazy or dumb or something by using the blank identifier. There's actually a good reason for it. If I did receive error here and then checked it, it might look from the test as though I'm testing that it doesn't return error. But I'm not. I already tested that over here. So having your tests only test the thing they're testing is quite a good principle, isn't it?
Yes, absolutely.
Don't accidentally test everything else as well, otherwise you get a very fragile test suite because literally any change is just going to break everything.
Correct.
So we have a game. So what do we do with it then? I mean, when we call display state, for example, what state?
That's just the current state that the initial state basically. Display state is just whatever the state is at that point.
Yeah, but for which game? You know, now that you can have multiple games, there's no way to know, is there?
Yeah. So
what could we do here?
Current game. So which game is it?
We have the game.
Yes.
And it has the correct state, and we have the display state function. We just need to connect the two things together somehow.
Yep. So is it game.display? Because display state is outside, so game.
Yeah, you could imagine that display state is a method on game, couldn't you?
It's a method on game basically. So yeah, so game.display state something. Should we change that on the right? It becomes.
Yeah, what other options have we got? We could also pass the game into display state, couldn't we?
Yeah, we could. Yes, we could do that current. I think that might be better. Yes. So it knows which game it is.
Yeah, the thing is, you could imagine quite a few things where, if you think ahead a little bit, like we were going to write read thrust, that's also going to need to take a game, isn't it?
Yes.
Because it's modifying the state of the game, if you like, changing this thrust setting. So we're probably going to have a bunch of things, each of which must take the game or not be able to work. And when you have that, it starts to sound like they're all methods on the same object, doesn't it?
They do, exactly. That's what I was thinking, yeah.
Because it's kind of saying, you know, writing a method is not just syntactic sugar. For saving, you have to add a parameter here. It's saying this is not just another parameter to the function, it's the key parameter without which nothing can work. In fact, maybe the method is specifically about modifying that parameter, isn't it?
Yes.
Which it is in the read thrust.
It is in this case, yes.
Yeah. So let's go with that.
That's what I was thinking.
That sounds good.
Yeah.
So we've got the game from new game. We've called display state on it, and we've given it a buffer to write to, and then we can check that. So that's good. Let's change this to be the method. Does it need to be a pointer method?
That's a great question.
Let's rephrase the question as: does it need to modify the game? Which is exactly what we're asking, isn't it?
Exactly, that's what we're asking. Yes.
If it needs to modify the game, it must take a pointer, otherwise it can't. And if it doesn't, then it doesn't. So does it modify the game, in fact?
It does modify the game, right? In this case.
Does it?
No, we're just displaying state. No, display state will not modify the game.
Yeah, display state doesn't
modify. Display state will not. Sorry, yeah.
At the moment.
And the future, the thrust and stuff might modify the game, but not at the moment. Display state is just printing it out what we have, the current state.
Yeah, I mean, what it does modify is the writer, isn't it? By writing to it. So you could say, as long as the output writer is an injected dependency, if you want to say it that way, then this is not a pointer method. But if you could imagine that the writer was an attribute of the game, for example, couldn't you?
Read, yes.
Like if you had a game window, like a GUI window, the game would need to know which window it is so that it can write to it,
Yes.
or draw to it. So that would probably we'd probably just have a field window on the game struct, wouldn't we?
Correct. Yes, that would be a writer, and that would make sense for a pointer at that point. Yeah.
So you could imagine that right now you have to pass in a writer to display state, even if you're the main.go.
Yes.
Which is a bit awkward because now you have to write extra code in main saying, yeah, I want you to write to os.stodout, and what other choice is there really? So you might say, actually, we could make that a default. So you can just call under.displaystate and it prints the standard out, unless you would like to override that with something, which we would in the test.
Yes.
In the test, we would like to override it with a bytes buffer. So you might say, you could imagine game equals new game, game.output equals buff or something, couldn't you?
Yes, we could do that, yeah.
I sort of feel like we don't need to do that yet, but let's hold that in reserve.
Yes, that's what I'm thinking.
Because what tends to happen is as you refactor one thing or extend one thing, you keep spotting ideas for other things that you could do, isn't it? So you need to kind of hold those without ending up with this huge stack of refactorings, and then you forget what it was you were doing in the first place, which that happens to me about 3 times per day. But never mind. So if you would help me unwind that stack and remind me what we were doing when we got to
we were going to write I think that's what we've done right now today. In fact, we're refactoring stuff. We were trying to do another test.
Oh yes, yeah, we're doing a game struct, aren't we? So
game struct, yes.
Yeah, so we've done that. So this test is still not going to pass because display state is not going to work because it can't read from this global which doesn't exist anymore. Can we fix that?
Let's fix that, yes.
Yeah, what can we do
the returns.
We can't talk to game state anymore. What can we look at instead?
Writer attitude game state, games that is no longer there, so display state. This is lander.go. This is the testing. I'm looking at the wrong function, sorry, yeah. So we look at the game basically. The game is what we'll be getting the details for it, right? We need to look at the input basically, which is, becomes right. G.
We're a method on the game. So
we're a method on the game, yeah.
We have access to it, so we can just look at G dot
altitude, G dot velocity, yes.
For those playing along at home, did you get it right? Comment on the video to let us know. So there's no more angry red lines on there, so I'm feeling good about that. Should we try the test?
We should try the test, yes.
Let's do it. Yeah.
Yes, that worked.
Happy with that. So let's check this one. Great. So I think we completed that refactoring. Now we have the game struct, so now we know how this test starts, isn't it? We need to get ourselves a new game.
Yes.
Because we need something to call read thrust on.
Correct.
So what's our want here? That's usually the first question we ask when writing a test, isn't it?
Yes. So in this case, this want is our thrust, basically, that whatever's reading it from. We should be wanting the thrust.
Yeah, so
the test, right?
If we start from the end and work backwards, so suppose we call read thrust, it prompts the user, they enter some thrust setting, and we return it. Or rather, we don't return it, do we? Because we're a method on the game, so what we'll be doing is setting g.thrust to whatever value was entered. So that kind of tells us our want, doesn't it? We want g.thrust to be, let's call this g.
Let's call it g, yeah.
And let's change it here, because it's a great thing for code to be self-similar. Anytime wherever you have the same kind of object, give it the same name. Like if you have a bytes
Correct.
buffer, always call it buff.
Yes.
Doesn't matter what name you use, just always use the same name, at least
Correct.
in the same code base.
Consistency. Yes.
So we want.
She doesn't
So
want
let's
us.
say, suppose it doesn't matter what we actually set it to, but let's say it's 10. So we want G thrust to be 10 at the end. Let's say. I think it starts out as 0, doesn't it? Yeah. So what's next?
Yeah, so the next thing is what are we getting and how do we get that?
Yeah, we need our
Is our
got,
got.
don't we?
Yeah.
So got is actually just G dot thrust, isn't it?
Yeah.
After the call. So we need to do the method call,
Method call, yes.
G dot read thrust,
Read thrust.
and then we look at G dot thrust afterwards, and we have our standard block.
If we want, exactly.
So these will be floats. Yeah, floats. So let's write it like this. So we just see 1 digit of precision after the decimal point. Okay. Now, does read thrust need to take anything?
That will be the input from the user or whatever. We might need something of that sort, right?
Yeah, well,
right now
remember we need to call this from main.go as well.
main dot, yes.
So we'll be saying g.read thrust, and the obvious question is where from?
Exactly, where from, yes.
So as you said earlier, we'll need a reader.
We need the reader, yes. So we can use, what do we want to create? A new reader, basically, some sort of. We'll need some sort of a standard in reader, but in this case, we can pass. In this case, right? Because this is we're mimicking the standard in this case as an example.
Yeah. So it's kind of symmetrical with display state, isn't it? In that display state needed a writer to write to, and we gave it a bytes buffer. Here we need a reader to read from. We could give it another buffer, couldn't we?
Another buffer, yeah. We could give it a read stuff, exactly, yes.
But a buffer that we put some stuff into beforehand.
Yes.
Ready to use. So suppose we did that. So let's make a bytes.
Bytes, basically.
If we do new buffer string, then we can start with new buffer string. Then we can start with a string, which is what we want, and it will create a bytes buffer with that string in it, if you like.
Yes.
It's helpful, isn't it? We could have just created a buffer, and then we could have said buff.writeString, so and so, but this just saves us that extra step. So let's say,
10, yeah.
Enter 10 new line.
Yeah.
I think it's new line, isn't it?
It's new line, yeah.
So we'd like to pass the buffer to, and we have to pass it a pointer, don't we?
The point, yes.
Because even with an IO reader, reading from it modifies it, weirdly enough, isn't it?
Yes.
That doesn't seem logical when you first think about it, but in fact a reader has some internal state because it knows where it is in the stream, if you like, how much it's read. And so therefore when you call read on it, you modify that internal state, therefore you want to send a pointer, so that's great. And we would also like something to print out to, because we're going to print something like please enter the thrust, aren't we?
Yes.
So like here, we're going to need somewhere to print that to.
Yes.
Okay, great. So let's do that then. So instead of buff, let's call that, what should we call it? This is our input now. So should we call this input?
Input, yeah, that's standard stuff, input.
Yeah, sounds. Go with the obvious name.
Go with
That's
the
my
obvious
rule of thumb
yes.
for this. So here's our input, and we'll also make output is just a bytes buffer.
Bytes buffer.
Same as we did before.
Same as here, yeah.
So we'll send it pointer to input, pointer to output, and it will hopefully print a prompt to output. We we can check that in the test.
Yes.
And it will read from input, hopefully,
Mm-hmm.
and pass that into a number and set g.thrust to be
Yeah.
that, which is good. So we can say to do check output. Yeah, and we it doesn't like. Yeah, so I
I
initialized one with a constant.
And one with a string in there.
Yeah, and it's a constant with no fractional part. So Go makes a
Yes.
decision here about what type should want be. You never said because you used colon equals to declare it. So I'm going to guess that int is what you want. It's not actually.
No.
So how could I force that to be a float? Any ideas?
10.0.
Yeah, I
That way.
could totally do that, couldn't I? I could, even though it's still 10, I could put a fractional part and therefore that forces it to be a float 64. Or I could be more verbose and I could say var want float 64, couldn't I? And then assign to it. But we're not going to do that because we're the smart party, so we're just going to do that. That's great. So we're out of time, so we better park it here. And your great work will be continued by someone else next time. We don't know who the victim will be, but someone of equal distinction to yourself. And thanks very much for your contribution this time. It's been great.
Thank you, John. Thank you for the opportunity. Appreciate it.
No problem. And I'll see you all next time.
Yeah, thank you.